Welcome. Question number 91. This is part 3, part C. Part C of moment of inertia calculation. I wrote dedicated to steel structures. So anybody who is going through this class, it is compulsory they should first study part A, part B, then only come to part C, because see these properties all, what is the meaning of this property, everything, RSJ, what is RSJ, channel, all told earlier. So unless you study part A and part B, part C will not be clear. So part C here now. Find moment of inertia about centroidal axis for a cross section of a steel member, some beam or column, okay, consisting of two RSJs, ISMB 350 as shown. See, one I section here, above that, one more, there is no gap here, it is central line diagram. Then in the question given, area equal to 6671 mm square, in the question only given. I told you, these all you are getting from IS handbook or steel tables. 13630, 0.3, 10 to the power 4, millimeter power 4, and IYY 537.7, 10 to the power 4, millimeter power 4. This is the question. See, these data are given because this comes in engineering mechanics. If you are studying engineering mechanics, you imagine these are given for you. But when you study steel structures, this is not given for you. You have to get it from IS handbook or steel table. Okay. Right, neat cross section. Actually, what happened is slightly turned here. Okay, I observed there. See, slightly turned this way. Okay, adjust it. Right, correctly vertically below other one. See, both are identical sections. So now, see now, first dimension. See, this width of flange is not given because it is not required. It is not required. If requirement is there, I would have given it here. And in steel structures also, if requirement is there, refer IS handbook. See, now, this is H. ISMB 350 means the depth H is how much? Depth H is 350 millimeter. I told you that number itself is the depth H. So, this is 350, see, up to here. This is 350, up to here. This also is 350. So, total is 700. Total is 700. Okay, now, make a note. Centroid, see here. This is centroid G for the I section somewhere here. Here, what you do is, you divide into two parts. See, once again, see, divide into two parts. What you will do is, see, this entire I section you are taking as one unit. I told already, repeatedly I told. See, this I hatch other way, this way. This I will take 1, this I will take 2. So this is properties for what? You can make a note here. This is properties for, see, these are the properties for both 1 and 2. For both 1 and 2. Okay, now, first you require area. Okay, right, area. Area is very simple. Area of one I section, how much? 6671. 6671 is area of one I section into 2 will give area in millimeter square. Okay, then we want moment of inertia about centroidal axis, XXYY. See here, pakka symmetrical. So this is your XX axis. See, it will come here, XX. So if this is 700, see, already there, 350. Don't have to write, it is already there, 350, 350. This is your YY axis, exactly through center. Or this is symmetrical about both XX and YY. YY. And that centroid G, where is it here? See, this is centroid G1, this is centroid G2. Okay, start. Area over. Now first find I about, see, YY, a little space problem. YY, okay. First find I about XX axis. Before that, usual statement you have to write parallax theorem, I about any axis equal to ij plus a square. If you cannot write, I told don't study from my class. Okay, start. Come here. I about, see, its own centroidal axis first. That is nothing but this axis. That is these all already more than 5-6 questions are over. So now you should study correctly. That I is 13630, 13630.3 10 to the power 4. That is Ig. Plus area. 6671 is the area into from centroid G1 to x-axis axis, this is perpendicular square. See, this is 350, exactly center, this distance, you see, that is this distance is, you can see with the sketch only you can make out 350 by 2 whole square. Close the bracket. This will give, you should write I about xx for 1. What about for 2? See, identical. Once again, same Ig, same h square, or both 1 and 2 are placed symmetrically with respect to xx. So directly multiply by 2, get the answer. Then I about yy. See here, first I about its own centroidal axis. See here, it correctly coincides with, sorry, that axis, see this axis, coincides with yy. That is 537.7, 10 to the power 4, plus area 6671 into centroid G1 lies in yy. So perpendicular from G1 to yy, see vertical axis you are doing horizontal distance, or whenever the centroid lies in the required axis, directly multiplied by 0 square. This I told thousands of times, 0 square. Identical for this one, reason I told you, multiply by 2, you get I about yy for this action. Very simple question. Okay, next question, 92, is that interesting. Be careful, more work is there. 93 is somewhat a tricky question. I will tell you, it is asked in examination. 92. Okay. I'll write the question and write the properties and start. Next question, 92, is a special type of question. See, the cross section of a column, why it is used, you never bother. Worry in steel structures. Consists of two identical RSJs, ISMB 500, with another RSJ, ISHB 450, placed between them as shown below. Find moment of inertia about centroidal axis. In the question given, properties for ISMB 500 and also properties for ISHB 450, they are given. Now, they told, see here, here I write, properties of RSJ, it's a general, this is for any RSJ. Now, when you come to ISMB 500, see properties, I copied from there. When you want ISHB 450, I copied the properties there. This actually you get from handbook. In this class, it is given. Now, the sketch is drawn as neatly as possible, sufficient. Now, first of all, see, what is this section? What they told? Two identical RSJs and another RSJ in between. See, this is in between. So, the in between one is ISHB 450. And these two identical are ISMB 500. Therefore, this is property for this one and this one. This I will take 1, this I will take 2. So these are the properties for 1 and 2. This is the property for 3. So correctly make a note. Now, centroidal is no problem, perfect symmetrical. See, it will pass here. X-axis, through center here. See, exactly center. This is x-axis. And exactly in between, see, through this G3, this is YY. Okay, G3 I mark once again now. See, this is G3. It passes through G3. Okay, now start. First, area. Area is not a problem. Directly you can write the answer. Because why? See here. What all I dictate you write. Area for 1. See here. For 1. 11074. It is, you should write correctly. 11074 is area for 1. Same area for 2. Multiply by 2 plus this area. See, when you want to 1 and 2, see properties here. When you want for 3, see properties here. Sketch is same. That area is how much? 11789. 11789. Get the area, directly answer. Area why I find, it is required. Okay, now I about XX. Before finding I, usual statement you are right. Okay, then start. See here. First I'll do for 1, this one. I about its own center on the axis. I about this axis. When you want 1, you should see here. That is this axis. See, that axis for 1, I is 45218.3, 45218.3, 10 to the power 4, Ig, plus area is 11074 is the area into centroid G1 lies in XX. So into what? Into 0 square over. This is I for 1. I for 1 identical for 2. So multiply by 2 plus, be careful now. I about, see, whatever you got for 1 is same for 2. Now here, I, see, now careful. For 2, I about its own centroid of the axis. I about an axis passing through centroid parallel to x-axis is this axis. But this axis, see, this axis is not this axis. It is this axis here. See here. This axis is this axis. So property not here. For figure number 3, see here. 3045, you should observe this one. 3045, 10 to the power 4 is the Ig plus area 11789 is the area multiplied by, again centroid lies in YY, 0 square. 0 square. Calculate IXX. Get the answer over. Now, IYY, I want little more space. So what I will do, IXX I will rub out now. Already over now. See, now IYY. See, be very careful. IYY. Start. First, come here. For figure number 1. I about an axis passing through centroid, see, parallel to YY. It is this axis. This axis is same as this axis for figure number 1. 1369.8. 1369.8. 10 to the power 4 is Ig plus area is 11074 is the area multiplied by, see, from this centroid to YY, see, this distance square. That distance square is, see, from this is center of web. From here, this is center of web. See, this web thickness is how much? See there? That for this one, web thickness is given. Why given? It is required. That's why given 10 points. So 10.2 by 2, see here, from centroid here to YY, this distance square is 10.2 by 2. This is very important. See, 10.2 by 2 plus from here to here is, see, this distance. This distance. That distance is this distance. So that is your h is how much here? That distance, see, this distance is this distance for figure number 2 is h is 450. 450 mm. So plus 450 by 2. Why 450 by 2? See once again here, whole square. From here, we want from G1 to YY. This distance plus from here to here is, see, this distance. That distance is this distance in the J line. That distance is half of H. But that distance is, here see, for this member, this distance is H by 2, 450 by 2 whole square. This is IYY for figure number 1, multiply by 2 for this one. Next, IYY for this one, 3. I about its own center of the axis. This I about this axis is this I for part number 3. That is 30, see, we want this I. This YY parallel to YY is, see, this I is this one. So it is 4034.9, 4034.9, 0.9349.9, 10 to the power 4 Ig plus area is 11789 is the area into from centroid G3 to YY, G3 lies in YY, so into 0 square. 0 square. Okay, over. Calculate IYY. Question 92 over. Question 93 is a tricky question. See, this is asked in examination. This is asked in a competitive examination. Competitive examination. I will tell you what is the question. Very simple actually. If you have to use the brain, little logic required. If you understand, okay, otherwise understand whatever is possible for moment of inertia. What else I can tell? I write the question. Now, lastly today, come to question 93. With today, RSJs are over. Next class, I am starting channels. See, this question is asked in competitive examination and also in academic questions. I will tell you one thing. See here, the cross section of a column. Before that, the cross section of a column consists of two identical RSJs. Means both are same RSJs. ISMB 600 placed as shown. One this way and one this way. See there, placed. See, identical. Little scale problem is there. Maybe, okay, little bigger required here. That's all, don't bother. Draw how much is the size of this one, maintain same here. Okay, then see, one this way, touching each other. There is no gap because this is central line diagram. Question is, here in our class, question is, find least moment of inertia of cross section. And properties, they told only area, IXX, IYY. Even area also they may not give. Very important. That's all. Nothing else given. If requirement is there, you can write. See, therefore I wrote here. Properties of RSJ, H is 600. Why? ISMB 600. See, that is, this is 600 and this is 600. Then area given, I about this axis given, I about this axis given. Now, for those who are interested, I will tell you, this question came in strength of materials for the chapter columns, where the question was to find load carrying capacity of the column, either by Euler's formula, buckling load, pi square EI by L effective square, where I is the least moment of inertia of cross section. So if you go for Euler's buckling load formula, you require least moment of inertia of the cross section, whereas if you go to Rankine's formula, it is crushing stress into area by 1 plus Rankine constant alpha into lambda square, where lambda is slenderness ratio, L effective by least R equal to least I divided by area. So both the formula, whichever you apply, you require only least I. See, in that column chapter in strength of materials, not in structural engineering, because structural engineering, different effective length will come. In strength of materials, only least I is required. Least I required. That is, it is, see, there is one symmetry is there. So when symmetry is there, then those two axes are called principal axis. Even if one axis symmetry is there, see, this is symmetrical axis. By virtue of that being principal, other also principal. So least I is least I is I about xx or I about yy. See, I about yy, among the two, whichever is least. Whichever is least. That is the principle. This is for strength of materials. Okay, that's all for this question, you remember. But not if it's actually unsymmetrical about both the axes, then principal moment of inertia will come. Here, see, one symmetry is there, sufficient. If one symmetry axis is there, it can be either xx or yy, then least I is either ixx or iyy. So, in the question, they want only least I. Therefore, you find only least I. So now see, first write the cross section. This I will take 1, this I will take 2. Properties told, area is very simple. If you want 1561 into 2 is the area, leave it. Okay, these are the properties. See, this is property for both 1 and 2. 1 and 2 for both of them identical property. Now, see, ixx, how to find? First mark x-axis, see here. This is your x-axis. Exactly passes here. This is a very easy question. See. This is x-axis. Where is yy? There is no symmetry for yy. One thing guaranteed, yy will come somewhere when there are, see, both are equal areas. This I section, both are equal. Yy will come somewhere in between. Where we don't know, randomly mark here. See, we don't know where is yy. Let it come here. Yy axis. It will come in between. So, we do not know where is yy. First of all, make a note. This is centroid G. See, centroid G. Enough data is not given to locate yy. Actually, you can see, if you know all the properties, next class, see, we locate. Earlier you located A1 x1 plus A2 x2 divided by total area, you can do it. But data not given. This is a tricky question. See, this is a tricky question. You should think, or if you observe correctly, we do not know the distance. So do one thing. From this, leave it now as it is. You mark yy randomly. Where is yy? We don't know. Right here. Make a note here. Randomly marked. But one thing important, it is somewhere in between. Why? When the two identical RSJs are there, this centroid is here, this centroid is here, yy will come somewhere in between. Okay, leave it. Start. Ixx. Before that, usual story, start. I about, see, for figure number 1, for this RSJ, I about its own centroidal axis. This axis, nothing but this axis is 91831. Observe correctly, 91831, 10 to the power 4 is Ig, plus area is 15621 is the area, see, 156 area into, see here, centroid G1 lies in xx into 0 square. That is Ixx for 1, right here. This is for 1, you can make out that one. This is for 1. Then plus for 2, see, we want I about xx. Its centroid is here. I about an axis passing to centroid parallel to xx. Oh, same this axis. This axis is not this axis. See, I about its own centroidal axis parallel to xx is this axis. Here xx, there yy. How much it is? 2651 10 to the power 4 Ig plus area 15621 is the area into once again 0 square. Okay, leave it now. You will get some answer. The answer will come. I want the answer this time. See, 91831 plus 2651. is, calculator is not on. I will put 10 to the power 4 only. 91831 plus 2651 is 94482. Oh, like mobile number. 94482 is so many of my people, my contact name, that number is there. 94482. Okay. 94482. One number is known to me. 94482 10 to the power 4 millimeter power 4. 1 minute. I want to check the camera once, only once. Is it out of range? Yes, slightly out of range. So I will do one thing now. I will slightly shift the camera upside. So that, okay, now no problem. Because slightly out of camera. Okay. Okay, done. That is IXX. Now come to IYY. See correctly. That's why it's a tricky question. See here. We want I about YY. First of all, we don't know where is YY. No problem. Here, come here. Centroid is here. I about its own centroidal axis. See, this axis. That axis is nothing but, see, this axis. How much it is? 2651. It is 2651 10 to the power 4 is IG plus area is 15621 into from centroid G1 to YY axis. This distance square we don't know. You do one thing. Let this distance be H1. Perpendicular distance for figure number 1 into what? Into H1 square. We don't know what is H1. Leave it. No problem. Plus, come here. I about its own centroidal axis parallel to YY. This axis is this axis. That is 91831 10 to the power 4 plus area 15621 is the area into from centroid G2 to this axis. See, from here to here, this distance square, let it be H2 into H2 square over. Or if you calculate, it will come 2651 10 to the power 4 plus 91831 10 to the power 4 is how much? It is 94482 10 to the power 4 plus 15621 area into H1 square plus H2 square. H1 square plus H2 square over. Oh, now you got the answer. See, IXX is 94482 10 to the power 4. IYY is 94482 10 to the power 4. Same number plus something. Therefore, right here. Therefore, 100% I about XX is less than I about YY. Why? What number came here? This number came here. What number came here? It came here. And there are two zero squares here. Instead of zero square, some distance square is there. So you can make out I about XX is less than YY. Therefore, you can tell least I is IXX itself equal to 94482 10 to the power 4 millimeter power 4. The question in the competitive examination is to test this one. By looking only you can make out. See, somebody should think. Someone will feel what tension. What is this one? How to find moment of inertia? Think. This data is given in the question paper. It is asked in IES, I think. Most probably we call Indian Engineering Service, or one more name people are using for IES. I don't know what is the name. In North India they use some other name. Okay. I forgot the name used there. One is IAS, other IES, they use some other name. Okay, then see, you should think a little. I about XX is this IXX plus for this one IYY, that's all. Both centroid lie in XX. But when you do YY, this XX will be replaced by whatever, see, YY for that one will be XX here, whatever XX here, Y here. It is IXX is something plus something. IYY is same thing plus further something. Why? Area into distance square will be there. So if you think that much, this question, see, directly least I equal to sum of these two. Once you know the concept, without writing any sketch, you can solve this question. See, for the column, suppose the question is you require area and I, least I. What you do? Multiply the area by 2. Area, you get it. Then add these two I, moment of inertia. One of them is IXX, that is for this one. Other is IYY. You add those two. And forget about the other axis. Why? Other axis answer is whatever you got just now plus something more. Therefore, least I is directly equal to sum of these two. Then pi square EI by L effective square was it's actually Euler's formula was given there. I remember. Pi square is known. E they given in the question paper. I is this I. How much? 9448 10 to the power 6. Defective length in the question paper given. Or if they ask Rankine's formula, least I by area will give R, least R. L effective by R will give centerness ratio. Substitute, you get the answer. Maximum time required is 1 minute. If you know this concept. Otherwise, suppose you want to locate centroid and do it, you will end up here. See, you start wondering how to locate YY, no distance was given. Yes, it is not required because IYY is coming more than IXX. That's why I told tricky question. So in case if you write an examination, by chance this question comes, remember then least I is these two summation itself is least I. You should remember it. Okay, now over. 93 over, next 94, I'll make a note here. Okay, now. Next class, very, very important, channel sections, where one symmetry is there, other is not symmetrical. And maximum questions on columns in examination, steel structures, in examinations all, they give for channels, then they give for angles. So, next class will be channel section. I think one class is sufficient mostly for channel. Then one last class for angles. And one class for gantry girder. Little big question it is. Maybe 3 more classes required. 3 or 4. Okay. Then I will once again go back to leave all this one. All this for meant for, I told, dedicated to steel structures. Okay. Thank you.